Everyone, here is a video for chapter 4, section 4 and 5. We are going to be looking at setting up matrix equations and how to solve using those, and then we are also going to use the calculator to find inverses and to solve. So we have this set of the system of equations here, and we're going to use a matrix equation for this system, but before we do that we should talk about the process that we're going to have. So say we have a matrix A and our variable, so we'll pretend like it's not even a matrix. A times X equals B. And say we're trying to solve for X. Well, normally we would divide each side by A, right? And then X would just be equal to B divided by A. But we can't do that with matrices. We don't divide by matrices, we can only multiply. So what we should do is go back, and instead of dividing by A, we could think of this as multiplying by 1 over A, right? Because if we had 2 and we wanted to get rid of it, if we multiplied it by 1/2, it would cancel out. So if we multiplied both sides by 1 over A, that would cancel out, and then I would have X equals 1 over A times B. But I know that looking back over here, 2 and 1/2, those are inverses. So another way that I could write 1/2, and we'll talk more about this later, but 2 to the negative 1 is 1/2. The inverse of 2 is 1/2. So maybe instead of writing 1 over A, if I write A to the negative 1, the inverse of A, if I multiply that on each side, A and inverse of A cancel out to just be 1, or the identity matrix when we're looking at matrices. So then X will be equal to A to the negative 1, so the inverse of A, times B. So we're actually going to be looking to set up our matrices in this way. We'll solve for our variables by taking our inverse matrix of A and multiplying it by B, which is going to end up being our constant matrix. So let me show you what I'm talking about here. Let me erase all of this. Okay, so let's look at setting up our matrix A. Our matrix A, so if you notice we have up here, we have 1x and 1y. We have 2x and then 1y. Always make sure that your equations are set up in this way: x plus y, ax plus by equals c. So your x, then your y, then your equal sign, then your constant. We're going to take those numbers, this 1, 1, 2, and 1, and that will make up our matrix A. So we have 1, 1, 2, and 1. And it's really important that your x and y are in the same order so that way your matrix doesn't get messed up. Okay, now let me erase all of that so you can see what I'm doing. There's that 1x, 1y, 1y. I'm going to multiply this by x. My variable, we're solving for my variables. Well, I have two variables here. I have x and y, so I could set this up as x and y. And then I have equals b, which is my constant matrix. So I'll have equals, and then my constants are 8 and 1. So remember before we figured out that x could be equal to a to the negative 1 times b. So what I need to find is my inverse matrix A. So that way when I multiply this side by a to the negative 1, I multiply this side by a to the negative 1, these will cancel out and I'll have my solution. So I need to find my inverse matrix. Okay, so looking at our matrix 1, 1, 2, 1, first I need to find the determinant. So if this is my matrix A, the determinant of A equals, so 1 times 1 is 1 minus my other diagonal multiplied is 2. So that equals negative 1. So my determinant is negative 1, so it does have an inverse. So we will be able to find an inverse matrix. And then my inverse matrix A to the negative 1 will be 1 over my determinant, which is negative 1, times, so remember we flip the first diagonal, they switch spots, and then the other diagonal we multiply by negative 1. So that's negative 1 and negative 2. Now we just distribute. This just equals -1, so I'm multiplying everything in here by -1. So my inverse matrix is -1, +1, +2, -1. So there's my inverse matrix. You may have noticed that I always put a to the -1 in front. Well, that's because looking at the dimensions of my inverse matrix, well, the dimensions of my inverse matrix, that's a 2 by 2, 2 rows, 2 columns. Looking at my dimensions for this one, I have 2 rows and 1 column. The trick to this working is you have to multiply them in the same way. So if my a to the -1 is a 2 by 2 and my b is a 2 by 1, you always have to multiply them in the right order so that way the middle numbers match. You won't really get to experience much of why it works this way, but it has to do with how matrices are multiplied. So we have to multiply it in so that the two middle numbers are the same. So it's 2 by 2 and 2 by 1. The 2's were the same in the middle, so I should multiply my a to the -1, my inverse matrix of a, times my b. Okay, so now I have x, so I've got x and y, right? Maybe it's better if I use the same colors so I can make that green. Okay, so here's x, and then equals my a inverse goes next, and that matrix is -1, 1, 2, and -1. And then we have to multiply it by b. And remember, b is just my constant matrix, 8, 1. So basically all you really need to know every time you're setting these up is that you're going to multiply it in this way. Once you set it up, you're going to have a inverse times b will solve your equation for x and y. So let's switch over to the calculator, and we're going to type in this part, this first matrix times the second matrix, a inverse times b. Okay, so here I am, I'm just on a calculator page, and I'm going to do a inverse times b. So to find the matrices, I believe you click on this button, there we go, the one next to the number 9. If you click on, so there is one right here, it's already a 2 by 2, so we can click on that one. And then you just fill in the blank. So our a inverse was -1. Our next one was +1, then 2, and then -1. I'm going to click out of it to get out of that. Then we're going to multiply that by b, our constant matrix. So we'll click back on this button again. Here's a 2 by 1. So just so you know, here's a 2 by 2, a 1 by 2, a 2 by 1, and then this one, even though it looks like a 3 by 3, when you click on it, it gives you an option to fill in whatever you wanted. So if you wanted to use that one, you could. But I'm going to use this one. And so then our constant matrix was 8, 1. And then you just hit enter. And so then this top number is x, and this bottom number is y. So we have -7, 15. So let's switch back over. So now we know that xy, when we typed it into the calculator, we got -7, 15. So my x is -7, and my y is 15. Now, I've just reviewed how to find the inverse matrix, but actually your calculator can find your inverse matrix for you. So, switching back over to the calculator, using this same problem, and using just our A matrix here, let me see, I'm going to use my matrix A and my matrix B, and my calculator will solve it for me. I don't have to find the inverse myself. So, I'm going to type in my matrix A. So my matrix A, before we found any inverses or anything, was 1, 1, 2, whoops, going back here, 2, and then 1. So say you only wanted to find the inverse matrix, we're not even looking at solving yet, you could raise it to the power of -1 and hit enter, and look, there's your inverse matrix. And I know some of you are groaning right now, well, why didn't we just learn this in the first place? Well, we wanted you to know how to find the inverse matrix by hand. So if you just type in your matrix and raise it to the -1 power, it will give you your inverse matrix. So similarly, if I type in my matrix again, 1, 1, 2, 1, to the -1 power. So here's my A matrix raised to the -1 means A inverse. And then multiply it by my matrix B, 8, 1. There's A inverse times B, and there's your solution. So I know this is a bit faster. You could do it that way. Then of course, we do have our system solver where we could have just typed in x plus y equals 8 and 2x plus y, y equals 1, and hit enter and gotten the same answer. But you do need to know how to set up the matrix equation, figure out what A and X and B are. So you do need to know both parts of this. Then as far as typing it into the calculator to get your answer, it's up to you. Alright, hopefully you took notes on that and you know how to set up a matrix equation. Don't forget, you may have a quiz tomorrow. We'll see. Have a great day. Bye.